Okay, so we're going to be talking about inverse trigonometric functions, but first off, let's recall what an inverse function is. So if I have this function, it's a linear function, y equals 4x plus 5, we can find the inverse function to be x minus 5 divided by 4, and we get that by switching the x and the y and solving for y. Now, if I plug into this function x is equal to 2, that's going to give me y is equal to 13. Well, notice with the inverse function, if I plug in x is equal to 13, I get that y is equal to 2. So what an inverse function does is it switches the input and the output. It switches the x and the y variables, what we get in, what we get out. So an inverse trigonometric function works in the same way. So if I have the sine of pi over 4 is equal to root 2 over 2, I know that. What's the inverse sine of root 2 over 2? Well, simply put, it's just going to be pi over 4, right? Because the sine of pi over 4 is equal to root 2 over 2. So this question is saying, all right, what angle gave me a sine value of root 2 over 2? And the answer is pi over 4. Now, if you're really sharp, you probably realize that 3 pi over 4 also has a sine of root 2 over 2. But we don't include that. And so we're going to go through and look at sine, cosine, and tangent individually to explore this further. So here's the unit circle, and first off, realize this notation. So if I have y is equal to the inverse sine of x, you will sometimes see arcsine. These are the same exact thing. So if you see inverse sine of x or arcsine of x, they are the exact same. And that goes for cosine and tangent as well. It's just a different way. So you may see them written either way, but they mean the exact same thing. So arcsine of x is the inverse sine. Okay, now if I look at this unit circle, I have to think about what is the largest value sine could be. Well, because sine is really the y value, notice that these y values are increasing until we get here. And so the largest that y could be is 1. The largest my sine value could be here is 1. The least amount that my sine could be is negative 1. So for here, for my domain, x is going to be between negative 1 and positive 1. I can't take the inverse sine of something greater than 1 because there is no angle that will give me a sine greater than 1. I can't take the inverse sine of something less than 1 because there is no angle that will give me a sine less than negative 1. So that's how we get this domain. Now, if we realize that we start here at 0 and we measure our angles in the positive direction here, notice what's happening with these sine values, 1/2, root 2 over 2, root 3 over 2. Well, if I continue this way, I'm going to get those exact same sine values. So I'm going to actually exclude them from my results, because otherwise I'm going to have more than one answer. But if I move in the negative direction here, then notice I get negative values. So I don't get 1/2, I get negative 1/2. Those are different values. And so where do we go from? Well, if I move in this positive direction, then I could get any angle from 0 to pi over 2. Right? So the inverse sine of 1, with 1 being my x value here, gives me an angle of pi over 2. Gives me that output variable y of pi over 2. That's the largest that I can have. Now if I go in my negative direction, then notice I get down here, but I don't say 3 pi over 2. Because if I get 3 pi over 2, then I could have anything over here as well. And that's not the case. Remember, we're avoiding those because those are duplicates. So I move in the negative direction, and I get negative pi over 2. So this is key for us, this range of values. Our range must be between negative pi over 2, negative pi over 2 and pi over 2. We're going to look at some examples, and we're going to be getting lots of practice. But, you know, if I say, all right, what's the inverse sine of root 3 over 2? It's asking me, where do I get a y value of root 3 over 2? Well, I get them in these two locations. However, I'm only going to include pi over 3 because 2 pi over 3 is outside of this range. I cannot have an answer that's larger than pi over 2. And 2 pi over 3, you can see it's greater than that. So we need to be careful there. Now the same approach applies for cosine. So cosine, remember, in the unit circle is the x value, the x coordinate. So what is the largest x coordinate I could have? It's over here, it's 1. And the smallest value I could have is negative 1. So our domain for cosine is the same, right? Negative 1 to positive 1. But what about the range? Well, we start here. This is our initial side for the angle, and we open up in the positive direction. But we're connecting this angle over here. So where do we go from? We go from 0 to pi. What is, if I do what is the inverse cosine of pi, you know, what is the angle, or sorry, the inverse cosine of negative 1, what is the angle that gives me a cosine value of negative 1? Ah, well, the answer is pi. It's that angle there. What is the angle that gives me a cosine of 1? Oh, it's 0. So this domain, or sorry, this domain and range, these are important values here. And notice we don't have duplicates this way. So if I look at the cosine of pi over 6, you know, inverse cosine of cosine of pi over 6 is root 3 over 2. Cosine of 5 pi over 6, that's negative root 3 over 2. Those are different values. Now, if I say, hey, what's the inverse cosine of, we'll do that same thing, root 3 over 2. Well, we get two values. Notice there are two values, or two angles on the unit circle that have a cosine of 3 pi over 2. But this value, 11 pi over 6, is greater than pi. It's outside of our range. So we can only include pi over 6. And that's my answer. Now, if you look through the textbook, they actually go through graphical reasons for this. We have not looked at graphing yet, graphing functions, so it's not going to make the most sense right now to go in and talk about the graphs. But when we look at graphing, we will refer back to this and consider, because in the graph for the cosine function or the sine function, these ranges are actually where the functions are increasing. So that is one reason we get these values. But what you need to focus on, though, is notice that we don't have any duplicates here. Tangent's going to be nice and simple. So tangent, the range is actually the same as our sine function. So this whole area there. And the domain is going to be all real numbers. So you're not limited to anything between -1 and 1 for a tangent. Okay. Now, one thing we do want to look at. Inverse tangent of -1. This is a good question. So the inverse tangent of -1. Well, hopefully we realize tangent is y divided by x. So if I'm dividing something by itself, I'm going to get 1. If I'm dividing opposites, I'm going to get -1. So where am I going to have a -1? I'm going to have a tangent of -1 at 3 pi over 4. And I'm going to have a tangent of -1 at 7 pi over 4. So what's the correct answer? Well, remember, for the tangent, we're looking at our values. So y must be between pi over 2 and -pi over 2. So that eliminates 3 pi over 4. And a number of people will say, oh, it's 7 pi over 4. But that's also wrong. Because if you were to have a number line from -pi over 2 to pi over 2, and I said, all right, put 7 pi over 4 on that number line. 7 pi over 4 is greater than pi over 2. Right? This is greater than pi. So it won't fit. So does it mean there's no solution? No. No, it doesn't. Because this is over here not labeled in blue. This area doesn't exist. Right? So just imagine that this is all just blank area. So we get this. Well, how do we get to this angle, 7 pi over 4, if we start over here? We have to move in the negative direction. And this is -pi over 4. So the answer is -pi over 4. Now, if you want to, you can remember, oh, it's going to be between -pi over 2 and pi over 2. So if you have 7 pi over 4, you can find the coterminal angle by subtracting 8 pi over 4 to get that -pi over 4. That's another method of doing this and taking care of this. That's completely fine. It will get you the correct answer. There are other rules out there as well and other ways to remember this. So most obvious, I think, is the sine. So notice, if you're asking for the inverse sine, you're asking for which angle gives you a y value. Well, because you can only have up here, which is positive, and down here, which is negative, whenever you take the inverse sine of a negative angle, you're going to have a negative answer. So if we were to say, all right, what's the inverse sine of -√3 over 2? So -√3 over 2 is down here. We would not say 5 pi over 3, again, because that's outside the range. We would say that's -pi over 3. And you can look at the similarities there. So that's one way to really think about this and to kind of hopefully make this a little bit easier. Luckily for cosine, we don't have that issue because here, notice the range is between 0 and pi. You're only dealing with positive angles here. So you don't have that same issue. All right, so this is kind of some complicated stuff. It's conceptually a lot bigger and grander than what we've been working on. We're going to be getting lots of practice in class, and so just make sure that you review this and get lots of practice yourself.